What's up, children? How you guys doing? Mr. Dillo back again. Okay, we're gonna finish up our evolution talk. We're gonna summarize what we did yesterday, and then we're gonna learn some new stuff today. I hope you guys are doing great. Hope you guys are doing well. Hope you guys are doing fabulous. We're gonna have tomorrow's a holiday, so no work tomorrow, just to finish anything that you haven't done this week. You guys have done a really good job. Most of you guys have done a great job on doing the assignments. So if you haven't done those assignments, go ahead, go in the Google Classroom. I also started putting in grades, so check your grades to give you kind of an idea of where you're at. Other than that, let's get into it. Let's go. All right. So yesterday we talked about evolution, okay? And we talked about kind of what it was, natural selection. We have a bunch of definitions that we got to know, but it's okay. It's easy. We'll take it slow. So when you look at this, guys, okay, all living things evolved from a common ancestor. And the picture I showed you was the dogs, okay? These are our modern day dogs that we have here, okay? And you can see that as we follow them back, they all evolved from a wolf, okay? That wolf was the common ancestor. And I think most of you guys would agree with me on that, okay? So every living thing came from a common ancestor. So we're all kind of related in some way, somehow. To evolve as a basic definition means to change over time. Many things have evolved. Cell phones, shoes, clothing, hairstyles, those have all changed over time, okay? So natural selection requires populations to adapt and reproduce. Now, this is very important. There are two parts you got to remember. Natural selection, and think of it, it's the way nature is selecting who's going to survive. That's really what natural selection is. Nature selects who will survive. And how do you do that? You have to have good adaptations. It has to be within a population, and you have to pass those adaptations to your offspring. That is how the population. If you are not able, if you do not have the adaptations, you do not pass those genes on to your offspring, then your species will go extinct. Okay, and you can think of many dinosaurs. Okay, they did not have the adaptations to survive on this planet, so they went extinct. They were too big. Okay, we're going to watch a video next week about that. It's really cool and amazing. All right. So how does natural selection occur? How are some animals better than others? Why do we have coyotes here? Why don't we have dinosaurs anymore? Well, the dodo, those animals, where did they go? And how do we natural select? How does that happen? Well, basically there's a couple principles, and it's very simple, okay? If we're looking right here, would you agree with me that there are genetic differences within a population? Any population, are there genetic differences? Are there genetic differences between you and me? Are there genetic differences between your family, you and your family? Absolutely. You are 99.9% genetically identical to each other, okay? That 1% is different, but that's good because we talked about that. Why do we want genetic variation? Why don't we want all of us to have the same immune system? We're going through it right now, okay? So you agree with me that one, there are genetic differences. Some are tall, some are short, some animals are darker, some animals are lighter, some are faster, some are slower, okay? So we're looking at this population of giraffes, and you can see, are there genetic differences between them? Yeah, some have really long necks, some have medium necks, some have really short necks, okay? And giraffes are actually kind of smaller. They're like the size of the deer. So moving on. Those organisms with better adaptations will survive longer and reproduce. Do you agree with that? Do you agree that organisms that have better adaptations are going to survive longer and reproduce? Yes or no? Yes. Okay, good. We're fine. We're good, right? So one, you agree with me that in a population, there are genetic differences. Some are big, some are small, some are fast, some are short. Some have better vision, some have better vision. Okay, good. Do you agree with me that those that have better adaptations will survive and reproduce? Good. So over time, their offsprings are going to have those adaptations as well. So the question is, well, what happens to the organisms that don't have those good adaptations? Like these little baby giraffes, oh, they're so cute. Well, what's going to end up happening to these little cute little guys is they're going to get killed. Okay, dead. And the reason why is because they are not adapted to the environment. Can these guys reach their food source right here? No. I know this is a bit of an exaggeration here, but the point is still true. These guys are not able to eat. They can't reach. And last I checked, if you don't eat food, you don't live very long. Okay? Also, these animals that do have long necks, they're not going to be like, oh, he's so cute. Let's help him out. Let's have babies with him. No, they're going to be like, I don't want my babies to have short necks and die. So they won't even get any giraffe love either. And therefore, when they go, what else goes with them? Their bad traits. So over millions of years after this, are we going to have any giraffes with short, small necks? No. That is natural selection. All right. So what proof do you have of this, Mr. Dello? You're telling me that this. I'm with you. I feel you. What proof? All right, we got a couple of things. I got 10 minutes. All right, stick with me. So the very first thing we look at is the fossil record. I'm going to blow your minds with some of these. All right, guys. So very first thing is we have the fossil record, and this helps us determine how the land has changed, how the Earth has changed. So if I'm looking at this, and I'm looking at A goes here, shell, fern, leaf, I can tell you at this point, and this is current, so this is like right now. If we go there right now, what are we going to see? This is how it was back millions of years ago. So if I go to this area right now, and I look at it, most likely this is all going to be covered in water. Why is that? Well, because there are fish skeletons there, okay? There are fish skeletons here. So this has got to be all water because we found the fossils there. But as we kept going down, we could say, all right, well, there's water probably here too. Boom, boom, boom. But we get down to this bottom, and there's a hardwood tree. Well, last I checked, these trees do not grow in bodies of water. So that tells us that this area at once did not have a body of water. At one point, this did not have a body of water. So that gives us an identification of what is happening to this area, okay? How has it changed? And if the area has changed, based on what you know about adaptations, you could also say that the organisms that live there are going to change as well, okay? Those who could better hunt in water may survive more. So we look at fossil record. Helps us give an idea how the land has evolved, and therefore the animals have evolved as well, okay? Look at this sexy guy right here. This is big dog right here, Charles Darwin, okay? You may have heard him before, Darwinism. People love referencing him. So he's the one who figured this all out, okay? He's the one, okay? It's called biogeography. The environment that an organism has influenced their evolution, okay? So he went to these islands, the Galapagos Islands on the HMS Beagle, okay? Don't need to know that, just some fun trivia for it. And he looked at these different tortoises on the island. There's also a story he used to ride them, okay? So he looked at these tortoises. We have the Pinta, which is over here. We have the Hood Island, which is a little bitty one here. And we have the Isabella, which is on the big island right here. They all probably evolved from the same common ancestor, okay? Most likely. This isn't a different tortoise. They're all evolved from the same one. But what could have possibly happened is that these all could have been one island at one point, okay? They could all have been connected. At one point, the water level, earthquakes, who knows? So the tortoises that were on this section of the island got stuck there. The tortoises that were on this section of the island got stuck there. Okay, Isabel here. But what he noticed is that he looked at their necks and he's like, these all came from the same ancestor, but why are their necks so different? Can you guys think of any reason why their necks would be different? Think about the giraffes. Give me a couple seconds. It was based off of their food source, okay? You could surmise, you could guess that the food source on the Hood Island is probably located what? Higher up. Okay, maybe on midway through bushes and stuff like that, on top of the bushes and stuff. So therefore, over millions of years, they evolved to have longer necks. This is literally in the same area. These guys, same area, same common ancestor, but these guys' necks evolved over time. Where the Isabella Island tortoise, its food source is probably where? On the ground somewhere, right? It's a short neck. Could the Isabella Island tortoise live on Hood Island? Probably not. Most likely it wouldn't be able to reach the food source. And just like the giraffes, it would die away if it was on that island. So it's got a good spot right here. Okay. Next one. Oh, good. Homologous structures. Homologous. Homo means what? Same or different? Same. So these are homologous structures. These are different organisms share similar body structures. I know this is crazy, but let's look at this right here. Okay. Can you guess which, looking at the fossils, can you guess which animal they belong to? So here's this one. What do you guys think it is? Shout it out on 3. 1, 2, 3. What about this one? What do you think this is? What organism? I don't know. What about this one? What do you think that one is? What do I live in? You should know that one. But if we look, I'm gonna reveal it. Ready, set, boom. So this is a bat, whale, cat, and human. But the thing is that they are different organisms. Yes, yes, okay, and they have different functions as well. But if we look here, the bat has the same amount of bones as all these other ones. Every single one of these organisms has the same bone structure. This is your femur, 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 femur. Okay, these are your radius and ulna right here in your forearm. They all have them, radius ulna, radius ulna, radius ulna, radius ulna. Your carpals, okay, and your wrist bones, they all have it. And your phalanges, phalanges, right there. So this gives us an idea that maybe we all do have a common ancestor. Maybe our bone structure is similar, so why not? Okay, let's look at this. Which organisms are closely related together? A, B, A to C, B to C. Which two are most closely related? And you're just looking at their bone structures. Go ahead. What do you think? We should have picked A and B, okay? And when we think about it, a whale and a dolphin have more things in common than they do with a shark. One, whale and dolphin are both mammals. They breathe oxygen, okay? They produce milk. Where the great white shark doesn't do that. Another thing, if you didn't know this, mammals' tails go up and down, and fish go side to side. It's an extra one for you. But based off of their bone structure, you guys figured out that these two are most related to each other, if not the same thing. They're a little different. So would you, if you think that these are closely related together, then that would make sense that we are closely related to other organisms. Okay, just like the cat. We go back, we are more closely probably related to the cat than we are to the bat, right? Right, makes sense. Are you with me so far? This is all evidences. So bone structure is another evidence of evolution. Okay? I don't know why I have a megalodon in there, to be honest with you, but that's a megalodon. That one tooth is as big as our head, but it's huge. I don't know why, but it's there. If we look at here, so here are some common ancestries. We can see, once again, bone structures. Once again, we did not evolve from a chimp or a monkey. We have a common ancestor with them, okay? But we can see why scientists believe that we are very similar. We look at our bone structures, we see that we have basically the same head shape, arms, okay? Obviously, they have a little bit different structures, but they live in different environments, okay? These guys got long, gibbons have long arms because they live primarily in the trees. They hang. Okay, they need them for that. All right. Let's see what else we got here. All right. This is kind of interesting. Some organs are reduced in size because they do not have a function. These are called vestigial organs. Everyone say vestigial on two. 1, 2. For example, a vestigial organ would be a tailbone or your appendix. At one point, they served a purpose. Once again, your tailbone, scientists think, evolved from because we evolved from an animal that had a tail, but we no longer needed a tail. We don't live in trees. We don't use it to hang or anything like that. So it went away. Once again, if you don't use it, if it's not good enough or if it's not beneficial, then you're probably going to lose it. We didn't need it anymore. Okay. Look at this picture. Really cool. Why does this whale have a femur? If you don't know, your femur is your thigh. Why the heck does a whale have a femur? I don't know. Let's find out. That's because it evolved from an organism that walked on land. Okay, this is basically how it evolved back. You can see that it started here, moved here, boom, boom. I know these are huge jumps, guys. These are millions of years. It wasn't like next day, but this is basically what happened. Pretty cool. This is a snake, and as you can see, those are legs on a snake. They're basically little leg buds, okay? Because snakes evolved from an organism that had legs. Okay? Last but not least, embryology. I'm gonna try to go as fast as I can. So one is a human, one is a cat. Which one do you think is which? Boom. There's our human. Okay. Last but not least, closely related organisms have more genes in common. Okay, so once again, we are 99.9 or 99.9% identical to each other based off those 4 letters, A, T, G, and C. As you can see, we have more common with the chimp. Okay. Last thing I want to show you is this right here. Which one's the human? Okay, 1, 2, 3, 4, 5. Place your bets. Answer it in the quiz. 1, 2, 3, 4, 5, and I will reveal it next.